So today's warm-up, we of course are continuing on with our rational number substitution, and of course applying that then to our order of operations as we solve a particular problem. So here's our first problem. We do have something that looks a little bit strange probably that we haven't really talked about until now, and that's having that negative sign outside the parentheses. The only thing it really means is that whatever's inside the parentheses, once we find the answer to what's inside the parentheses, then becomes negative. The thing we have to watch out for is if it's a negative number, then it then becomes the opposite of whatever that negative number is, which of course makes it positive. Because I know that we learned that a negative negative, of course, is positive. And that's because those negatives are always the opposite of. Whoops, why am I doing that? I have to replace the y with negative 9/10. Okay, so as always, we start out with parentheses. Ignore these parentheses because that's just separating one thing from the next. So I'm going to start with this right here. I'm going to ignore all of this for now. So I've got 3 minus negative 4/5. So, of course, I need to use my graphic organizer. I love eating apples and avocados. So I need to bring these down as improper fractions. I've got negative 3 over 1 minus negative 4 over 5. So the least common multiple, or the least common multiple of 1 and 5, of course, is 5. I need to then change these into their equivalent fractions, both of them some number over 5. It just so happens that they are both negative. I'm going to put the negative signs in there. So to get from 1 to 5, I know that I'm going to multiply times 5. So 3 times 5, of course, is 15. And this one is already 5, so I just need to replace it with the 4. My denominators are now the same, so I can ignore them. I'm going to add or subtract as usual. Negative 15 minus negative 4. I have a subtraction problem, so I'm going to stay, change, change, cha-cha-cha. And then the signs are different. Find the difference. So, of course, that's the difference of their absolute values. The absolute value of negative 15 is 15. The absolute value of positive 4 is 4. 15 minus 4 is 11. The larger absolute value is here, so it's negative 11. I now have my denominator and my numerator, and that gives me negative 11/5 as my answer. I know a lot of you really like to change that immediately to the mixed number, but you really shouldn't do that for the simple fact that we know that we're still going to be doing some things with that fraction, and you're just going to have to change it back. So I'm going to rewrite my expression. I've got negative 11/5 plus 1/3 times 9 squared minus negative 9/10 divided by 6. So I am done with my parentheses. I'm now moving on to my exponents. And I've got one exponent right here. That's 9 squared, which means 9 times 9. And that, of course, is 81. I am going to move on to my next page so that I can actually see, or excuse me, have room. So I'm going to write my problem. Negative 11/5 plus 1/3 times 81 minus negative 9/10 divided by 6. So parentheses are done, exponents are done. I am now moving on to multiplication and division in order from left to right. First thing I get to is right here. I'm going to ignore the rest of my problem for now. 1/3 times 81. 1/3 times 81. I, of course, put that over 1. I'm going to keep the top with the top and the bottom with the bottom. But before I do that, I should notice that I can cross cancel because 3 goes into both of these. The reason I so easily knew that 3 went into 81 is because 81 is divisible by 9. So that's what tells me that. So 3 divided by 3 is 1. 81 divided by 3. I don't know what that is off the top of my head, but I know 3 goes into 8 2 times, 2 left over, and 3 goes into 21 7 times. So now I keep the top with the top and the bottom with the bottom. That gives me 27 over 1, which of course is 27. Bring down the rest of my problem. I don't know why I keep having a problem writing that 0. It's kind of funny. Okay, so I now have some division to do right here. I'm going to rewrite that the way I'm used to looking at it when I'm dividing fractions. I've got -9/10 divided by 6. I'm going to make that 6 over 1. I need them both in their fraction form. As always, before I do anything, well, first of all, I'm dividing, so I get to do my math Macarena. So that's keep the first, flip the second, and now we multiply. Keep the top with the top and the bottom with the bottom. Before I do that, I do want to look across. I've got 9 and 6. I know they're both divisible by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. So then I multiply the top with the top and the bottom with the bottom. -3 times 1 is -3. 10 times 2 is 20. And of course, I'm moving on to the next page. Okay, so we're going to rewrite the problem from the previous page, which was -11/5 plus 27 minus -3/20. Now, a couple slides back, we did this right here. We got the -11/5. Now, unfortunately, or fortunately, now that I've caught it, we forgot that this was originally in parentheses. That was how we got in the original -11/5 was in parentheses, and there was a negative outside that parenthesis. So when there's a negative outside the parentheses, it means we apply the negative to whatever the answer is in here. So that means we have -11/5. Well, 2 negatives, as you know, makes a positive. So this really should be 11/5 plus 27 minus -3/20. So this makes things a little bit easier because I'm now going to change that positive 11/5 to its mixed number form, because the first thing I need to do is add it to 27. So since 27 is a whole number, I'm going to be adding it to a mixed number to make it easier. So 5 goes into 11 2 times with 1 left over. 2 1/5 plus 27. So I can just add my 2 whole numbers. 2 plus 27 is 29. And carry the mixed number over since it's just that one mixed number. And then bring down the rest of this problem. Minus -3/20. Now, I know that I've got a subtraction problem, so I get to stay, change, change, cha-cha-cha. Now I've got a simple addition problem here. So I'm going to add these two together. Let's, acknowledge the fact that I've got these two fractions here and the whole number. So because I'm adding, not subtracting, again, because I'm adding, not subtracting, I can just bring those fractions over and set up my graphic organizer. I
love eating apples and avocados. So my improper fractions, or in this case they're just fractions, 1/5 plus 3/20. So the least common multiple of 5 and 20, of course, is 20. So that means this is going to be some number over 20. Let's kind of fix this here, actually, so that really looks like an E, so we're not confused when we look back at it. So some number over 20 plus some another number over 20. I know that second number is 3/20 because that's what it started as. So I just have to say, how do I get from 5 to 20? Well, that's times 4. So 1 times 4 is 4. I can now ignore my denominators. I've got 4 plus 3, which I'm sure everybody knows is 7. Now I've got my numerator and denominator is 7/20. Bring that right over here. Bring down the 29 and 7/20. And that is my final answer.